All right, we're back. This is part 2. I've already had to turn my definition sheet over because you guys know I use a lot of room. I've had some questions about the whole function, like how do you find growth factor, how do you find growth rate, and what are those differences? So just a reminder, here's where we started. We started back here with our basic exponential growth and decay. And we said that R was the growth or decay rate. And so if you put that in as positive, that means you're growing. If it's negative, then that means you are losing money every time. And so let's talk a little bit about how you find those. So on the back, we're going to start with our word is growth or decay factor. And this is our letter B. And we see this in our parent function of an exponential function. So a, b, excuse me, to the x, where a is your start and b is your growth or decay. And you find your growth or decay factor by taking your most recent amount and you divide it by your previous. So we're going to look at that in table form, but you can do it in table form. You could find it from different points on the graph, reading left to right. They could just give you 2 ordered pairs and that would be enough to come up with this equation. So we're going to look at growth and decay. So this is going to be our growth example. And if we have this little table here where this is x, we can also call that time. This is y, and we can also call that the amount. Let's say you had these points, 0, 1, 2. I'm going to erase this a little bit so I have room. And then you had these points, 10, 15, 22.5. All right, so if we want to fill in our equation, we can say that our start value is 10. Because you can see that that is our y-intercept, and y-intercept is the same as the start. Our growth factor, we're going to find that by taking our most recent. You can either do the 22.5 or the 15, as long as you're going down in sequence. So I'm going to do the 15 and 10 because that is easier math. So here's my most recent, and the previous is 10. So I would get a growth factor of 1.5. And that would give me this equation. Y equals 10 times 1.5 to the x. All right. So that's growth. Let's look at decay. Really similar. So decay, if we have this chart, x and y, where this can still be time and that's still amount. Let's start with 0, 1, and 2. But here we're going to start high and we're going to go down. So we go 60, 36, 21.6. So I know A equals 60, but B is going to be most recent. I'm going to use 36 and 60 just because those are easier numbers, divided by my previous, and that gives me 0.6. So this equation would be y equals 60 times 0.6 to the x. All right, that's growth and decay factor. And we have one more thing that's slightly different. So if you need to pause, go ahead and pause and copy this down. But if we look at our exponential growth and decay, this whole section here really becomes B. But what if I just want to find my growth or decay rate? That's usually the interest, and that's slightly different. So we're going to have here growth or decay rate. That's the little r. And so you want to use consecutive, just like when you're finding B, x and y values. So r is going to be y2 minus y1. Does that kind of remind you of slope? All divided by just y1. So notice we don't have any x's in here because we're finding a percentage. So we're not finding slope, we're finding a percentage. So if we wanted to find out rate, I have this example. So let's say we had year, and this was population. So time and amount, x and y. Let's say our year is 2003, and then we have 2004. So our population in year one, say it's 150 million. Population in year 2004 is 120 million. So if we want to find the rate, not the growth factor, because the growth factor would be 120 divided by 150. We're going to have r equals 120 minus 150 divided all by 150. And that we get as a negative 0.2. All right? That's the difference between growth and decay rate and growth and decay factor. All right, I'll see you all tomorrow.